Magnetism. So first thing I want to talk about is charge. Charge is a property that causes particles to attract or repel. So protons are positive, electrons are negative. And so when we talk about electricity, we're talking about the movement of electrons. Because we know protons are in a nucleus and they don't move. So first thing we talk about is force of electricity. So we have an electric force would be positives and negatives interacting. We know that like charges repel each other. There's a force pushing them away. And opposites actually attract. So it's a force bringing them together. Electric field lines are lines that we can show, demonstrate, draw these forces that are acting between charged particles. And we're going to talk about three different types of charge transfer. The first one is by friction. So if when you rub objects together, like the cloth and the rod here, we're actually transferring electrons. So the electrons move over to the cloth. It now has a negative charge. And the acetate rod would actually take a positive charge. So by moving electrons, we generate a simple charge. We can do it by contact. So if you touch something that already has a charge, it can transfer electrons to or take electrons away from you. And finally, by induction. This is kind of a weird process, but there's no actually touching required. You induce a charge, or you induce the positive or negative to go to one side of an object based on the introduction of another charge, like that charged rod with the negative charge. And then you ground it, it dissipates the negative charge, and now you have a positive object. It doesn't require touching. So these are just different ways that we can transfer electrons initially and give charge to things. But when we talk about electricity, we're talking about electrons constantly moving. And the first concept with that is current. So current is how fast are they moving? What rate are these electrons moving? And with current, we talk about two different types of current. There's direct current and there's alternating current. Direct current is when electrons flow in a single direction. These are like batteries. There's a positive and negative end, and the electrons constantly move in a single direction. And when we draw it in an electric schematic, we can see a little short and long line there with a little space in between. Alternating current is actually when the electrons regularly reverse direction, so it goes back and forth, and that's the kind of electricity that comes out of the outlets that we have in our walls at home. And on a schematic, we draw this little circle with a squiggly line inside. Voltage is another concept. It's a little vague in idea, but it's a measure of electric potential. So if there's a positive and negative, like in a battery, there's a potential for an electric force, and that electric force potential is called voltage. The unit that we use is the volt. Resistance, again, it's resisting the flow, so it hinders the flow of electrons. So anything that has resistance, we're measuring how much it's slowing the flow of electrons, so measuring of the opposition of electron flow. The unit is the ohm. And when we talk about objects having resistance, wires or other resistors, they're affected by thickness, length, temperature, and what type of material there is. Some things that have near zero resistance are called superconductors, but they're not so vital to this conversation. We can also look at a relationship between voltage, current, and resistance. When we're talking about a circuit, we have something called Ohm's law, and that allows us to look at how changing voltage or current or resistance in a circuit would affect the other variables in the circuit. So you should be familiar with using Ohm's law. You'll get a lot of practice with that. Conductors and insulators, again, we talked about them earlier when we talked about heat conductors and insulators. For electricity, they're pretty much the same. They allow flow of electrons or hinder the flow of electrons. And the same ones that are good conductors of heat are generally good conductors of electricity. And the ones that insulate heat will generally insulate against electricity. Circuits and circuit diagrams, there's going to be a video for you to watch on how to draw them. But basically the idea is there's a path, a closed loop, and with electricity can flow through devices or objects and wires and give us power to do things. There are two ways to draw it. Again, the video should show you how to draw single path circuits, which are called in series. One device fails, the whole circuit fails. And the resistance is the sum of all the devices, where in a parallel circuit there are multiple paths. One device fails, the remaining still function, but the resistances are actually calculated with a 1 over R calculation. Fuses and circuit breakers. Fuse and circuit breakers are safety devices. They are rated to a certain current. When they exceed that current, they melt or break or burn out. Or in the case of circuit breakers, they'll actually flip or trip open. They're held by magnetic release. So when the current gets too high, the magnetism changes and they actually open up. And these are to help prevent fires and overloads that can lead to fires. So circuit breakers and fuses, again, are primarily safe devices rated by current. When they exceed that current, they burn out or open up and keep fires from happening. So how do we relate electricity and magnetism? Well, the major way we're going to do this is through a motor or a turbine. So the way motors work actually is they're coiled wire, because what we do know is that electric current through wire actually generates a magnetic field. And actually, if you coil it, you get stronger magnetic fields. And so by using this coiled wire, we generate a magnetic field. And within a motor, there are two magnets, a north and a south magnet. So what you're doing is you're constantly changing the direction of this flow through this motor, or you're actually generating a magnetic field that's repelled by those north and south. And so it gets this rod to spin, this axle to spin, and we have motion. So the electric motor is responsible in one form or another of nearly all electrical generation. It was invented by Nikola Tesla, but the idea is that a motor and a turbine are the same object. The motor is when it converts the electrical energy to physical or mechanical energy. And if you actually spin the motor, you'll actually generate electricity, and that's called a turbine.